Hello everybody, and thank you for joining me once again. Root Beer here, looking at question number 2 on the 2010 MMC Manitoba Mathematical Competition. So question 2, a performer asks the members of his audience to think of a number. They are asked to increase this number by 3, the result is to be multiplied by 2, 10 is subtracted from the new result, this latest result is divided by 2. When told the final result an audience member obtains, he immediately tells them their original number. What one-step formula can he use to convert the final result back into the original number? Interesting. Alright, so let's leave these particulars of the audience's number out of it by saying something like let n be the chosen number. So we're going to carry out those same calculations but with n in there, and then at the end we'll get something like n plus 1, and so the formula he could use to figure out n is just take the number that they gave him, the number that they told him at the end, and subtract 1, that sort of thing. So first step, we add 3. All right, we add 3, multiply by 2. So 2n plus 6. 10 is subtracted from that result, so now we're looking at 2n minus 4. And then the last thing we do is divide by 2. So that gets us back to n minus 2. So the audience member tells him x equal to n minus 2. To find n, is it a magician or an entertainer or something? A performer. The performer can just use x plus 2 equals n. Okay, we clearly say x is what he's been told. Here's the quick formula to get n, the original number chosen by the audience member. Okay, so that's 2a, very quick. 2b, a fair coin is tossed 4 times. What is the probability that it shows heads 3 times and tails only once? So we need to show heads 3 times, but they don't all have to be in a row. I think probably the easiest way to do this is just a very quick probability tree diagram. So we have the first flip, second flip, third flip, and fourth flip. So on the first flip, we can get either heads or tails. Each of them have probability of 1/2. On the second flip, we can have heads or tails. On the third flip, heads or tails. And finally on the fourth flip, heads or tails. So you get this big tree diagram that represents all the outcomes. Each branch represents what happens. So here we have heads first, then tails, then another tails, and finally heads. And we can figure out the probability of that happening by multiplying by the probabilities on each branch. Now, since it's a fair coin, each branch has a probability of 1/2. So each of these comes with a probability of 1/2 times 1/2 times 1/2 times 1/2, or 1/2 to the 4th, or 1/16. That's each outcome, even when you flip it 4 times, is equally likely. We just change what each of those probabilities is equal to. Okay. Now, for our purposes, we don't care about all the probabilities, all the possibilities, all the branches. We just care about those branches that have 3 heads and 1 tail. So we'll highlight those in red here. So we want 3 heads. Well, here's 3 heads in a row. Can't use that last head, gotta go tails. Okay, what if I had 2 heads, a tails, and then a head? Sure. A head, a tail, and 2 heads. Yeah, that works. And finally, a tail and 3 heads. Now, if you want some explanation as to why this works, and why we know we can stop and we don't have to keep hunting. If we imagine the 4 outcomes listed in a row, there's 4 that we can choose to be the single tails that we need, and the other 3 automatically have to be heads. So there's only going to be 4 outcomes that have 1 tail and 3 heads. You chose the third one to be tails, you have to go heads, heads, tails, heads. So in total for the probability, well, we just add all these up. 1/16 plus 1/16 plus 1/16 plus 1/16. And we can get 4/16 or 1/4. Now, if you could explain why it's 1/16, you don't need to for each branch, you don't need to draw the whole diagram. And if you know there's only going to be 4 outcomes and you can explain that easily, you don't need to be coloring these branches, and you could very quickly jump to 4 out of 16. But, if you didn't know that, if you were unsure if it was a weirder probability, like maybe 1/3 of the times we get heads and 2/3 of the times we get tails, that would change, and you probably should do a tree diagram at that point. But there's your answer, 1/4, and that finishes up 2B. In the next video, we're going to go through question number 3, so feel free to join me for that one. I'll see you guys next time.